Okay. Good morning. It looks like I'm broadcasting okay live from Westmont College. It is February 24th, Wednesday. We are about to go into Inception world here because I'm broadcasting myself. We are about to go into Inception world here because I'm broadcasting myself. We are about to go into Inception world here because I'm broadcasting myself. We are about to go into Inception world here because I'm broadcasting myself. We are about to go into Inception. All right, that's the end of broadcasting myself. Just turn down the music. All right, and we are ready for class. So broadcasting live in YouTube, monitoring chat, looking good. Cannot see this class. Monkeying with my tools here for a second. Great. All right, there we go. Reset. There we go, much better. All right, so good morning. Let's just have a word of prayer, just quick to recognize where we are and what we're doing. Dear Heavenly Father, thanks for this chance to learn. Thank you for the Lent season, a chance to practice self-sacrifice so that when the time comes to do it for real, when we're not under constraint, we are prepared spiritually and physically to continue to worship you in difficult times. We remember the folks that are harmed and have been harmed by COVID and pray for their health. Pray for the effective distribution of this vaccine for the pandemic. We're grateful at the miracle that the construction of these vaccines has been unbelievable. Also grateful for my daughter's friend who's doing well. Pray these things in Jesus' name, amen. So quick update, our friend is checking out of UCLA, a lot of rehabilitation to do, but is out of the immediate danger. So we're very grateful for that. That's created a change in mood in our house, which is wonderful. All right, let's look at the calendar real quick. There have been a few changes to the calendar. So on the screen, I'm broadcasting what I'm currently looking at in the world, and what I would like to do is broadcast a version of the calendar. That's my superpower, double broadcasting. Thank you for keeping me honest about double broadcasting. There we go. Hopefully that's fixed. All right, and here we are in looking at Canvas, and when I look at Canvas, we are today on Wednesday, February 24th, and the first thing I want to draw to your attention is that the assignments for Chapter 7, the chapter that we are currently going through, the chapter that is focusing on arrays and array lists, that has been extended by one class period. So it was due on Friday. Chapter 7 Technia is now due on Monday. Chapter 7 Episteme was due on Monday, and the Chapter 7 Episteme is now due on Wednesday. It's extending it by one lecture period so that I can cover what I want to cover at the pace that I want to cover it and give you a chance to digest it, and then you'll have a chance to work on it over the weekend. That has a little bit of a ripple effect going forward, but I don't think it's going to be drastic in terms of what we're going to see going forward. We pushed hard during the first few chapters of Java because many of the concepts had a good parallel to Python, at least at the higher level at which we think about things like loops and if statements, decision making. Some of the syntax is different, and understanding the different syntax between Python and Java is important. But the higher level thing that we try and teach in this program is not the syntax of the language, but how we use things like loops and objects in order to accomplish different kinds of goals. And I wanted to make some space later in the semester so that we could talk about some of these problem solving strategies that get away from the syntax of the language. You know, you want to build a cathedral, you have to learn how to lay bricks. Even if your point of what you're doing is not learning to lay bricks, you want to build a cathedral. Can't build a cathedral without learning to lay bricks. And it is the same way with computer programming and application development. You may want to change the world with your incredible app idea that you have, but if you can't write a program, you're not going to be able to do it. You'll have to hire someone. Maybe you'll get duped by someone who tells you that it's hard and it's not. Or maybe you'll think that it's easy and it's not. So knowing how to lay the bricks, knowing how to do the syntax is important, but it's not the goal. That's not why we're doing it. Some people really like laying bricks and get really into it, and they become artisans at bricklaying. But most of us like to focus on the higher level goals that we've got. So that's what we're doing, making a little bit of space for that. And this is one week where I would like to do that, spend a little bit of time. Another thing that has happened over the last few days, I guess yesterday, is I released the results of exam 1. And I would like to just run through some of those solutions with you to talk about some of the things that were consistent patterns, maybe in some cases of things that just I want to address as corrections. You should be able to see responses and answers in Canvas. It would help me to know whether or not that's true. But I'm going to try and see if I can bring this up on screen so that we can look at it. And what I'm going to try and do is do this without giving away someone's grade. So I'm going to try and look at it as a student and see if that works out for us. So I'm going to switch into student view, which you think would be easy. And you would think it would be under settings. Many people would think that. People that think that would be wrong. Why? What's going on? CS-030, student view, there it is. Button moves around. Problem with web applications and the people who make them is that they change stuff all the time. And so it's hard to keep track of things, and it makes me feel like a boomer. But I am not a boomer. I am Gen X, and I'm waiting for student view to take effect. All right, great. So here's student view. This should be what you're seeing. Let me pull up what happens when I look at exam 1. All right, exam 1 online. Let's see what we get. It is locked. Yeah, this is sort of what I was worried about. All right, let me see if I can look at it as an instructor and see if I can effectively show you what I need to show you. Leaving student view, going into exam 1, and let's see if we can do preview, if that'll help. Great, okay. So questions 2 through 49 were chosen from a pool of questions. Everyone had the same questions, but they were randomly selected and the answers were shuffled. Starting at 50, there was a pool of short answer questions. Let me see if I can go to that one. I'm clicking on 50 and nothing is happening, so I'm going to scroll down to 50. All right, now again, okay, so I was wrong. This doesn't seem right. I think oh no, that's right. Yeah. Starting at question 47, we got short answers. All right, so your question 47 may not be the same as my question 47, but the contents of question 47 you did have to address at some point. So I'll just go ahead and go through the order that's being presented in my preview quiz. Your order may be different, but the content is the same. All right, so let's start with this question. What does the following mystery method do? No errors in the code provided. This is a class. It is a public class. It is a bank account. As you look at this, what you can see is there's an instance variable called balance, and it is a type of a class called amount. Now, the amount class is not presented here, although it should invoke the same ideas about the amount class that we talked about in lecture over 2 or 3 lectures. Even if you didn't know that, even if you don't remember that, you can see how amount is used in the constructor for bank account. And in that constructor, you can see that a call to the amount constructor is made where we say new amount 00. And what this is doing is this is creating a new amount, a dollar amount. The 0 and 0 is dollars and cents. And then we're passing it to the other version of the constructor located here. And so this is sort of the primary, can't highlight. Okay, can't highlight. Let me see, how can I, what can I do to highlight something so that you can see it when Canvas won't let me? Let's try this. All right. Okay, so this is kind of what I want to show you right now. This right here is the primary constructor. When you want to use the bank account class, you call this and you pass it in the amount that should begin in the bank account. All right, and then we store that amount in this .balance, the instance variable that's written here. Now, it is a reference to an object. It's not an integer, for example, or a double, but it is an object that is keeping track of your balance nonetheless. Now, the question is, what does the mystery method do? And the mystery method is here. And you have to be able to visually parse this and understand the architecture in order to answer this correctly. So for starters, you can see that it is a public method, and that means that it's supposed to be used by people who are accessing this bank account class as an API programmer. It returns void, so it doesn't return anything. That's another thing to notice. Methods that don't return anything typically are mutators, meaning that they will change something about the class for future use of the class. In this case, what we're doing is we're changing the balance. So then what we have to do is we have to be able to parse the parameters. So when someone calls the mystery method, they have to pass in a reference to a bank account as the first parameter, and the name of that bank account parameter is going to be called that, T-H-A-T. This is a little bit of a distractor because that and this seem like they should be kind of from the same category, but they're not. This is a reference to the implicit object that contains this mystery method, like self in Java, but that is a parameter. They're both of the same type. They're both bank accounts, so in that way they are the same, but they're not parameters. They're both parameters, just one is. The second amount that's being passed in abstractly is a dollar amount. And we're going to work with that as a reference. What we do when someone calls this is we use the amount that's being passed in by the person who's calling it, and we subtract it from the current balance. So subtract must be a method that's part of the amount class. That subtract must be a method of the amount class. We assume that it's working there because in the instructions I said there's no errors in this code. So just given what you've got here, you can assume that the balance is having a certain amount subtracted from it as given by the parameter. So this object is having dollar amount taken from it, and the same amount that was taken from it is going to be added to the parameter that was passed in. And so this is effectively a transfer from one bank account to another. The money gets added to the bank accounts that's passed in as the transfer, and it gets subtracted from the object that is whose mystery method is being called. So the quick answer to this is that the answer is this does a transfer. And somewhere in your version, I don't know why Canvas doesn't show me, but in your version, there's an answer to this that will give you a little bit of, it'll give you the answer. Let me see if I can. Who knows? Oh, this is a preview. I'm not editing the quiz. This is a preview. Okay. All right, so that's the first one. Let's look at the other bank account method. In my version of the quiz, it's on 49. And so in this one, after asking you, or in a different question, asking you what mystery does, I ask you to use mystery by working in this bank account example class down here as an API programmer to use it. I asked you to call the constructor, and then I asked you to use the mystery method. Oh boy. Okay, so I want to show you the answer. All right, so I'm going to switch out of the Canvas preview. I'm going to go to keep editing, and I'm going to just pretend like I'm editing the quiz itself. Oh, I can't do that because it's in a question bank. I will not be deterred. Exam short answer. There we go. All right, wait for things to come in. There's our mystery method. All right, I'm in the editing interface here, and so what I want to do is I want to show you. Okay, great. All right, so here's the class where I ask you to use it, the question where I ask you to use it, and here's an example of what it looks like to be used. So let's see, let me show you that a little bit closer. All right, so what this code is going to do is make a bank account that starts with $20.50, make another one with $0, and then transfer $10 from the first one to the second one. So I'm going to call the constructor on the first, I'm going to call a bank account constructor. That corresponds to calling this, let's see, which one am I, oh, great, can't do that. Call the bank account constructor, and that corresponds to, come on, tools. I just started my program that writes novels. Can we just not do this right now? Let's not write a novel right now. Okay. All right, so oh gosh. All right, so here are my constructors that I'm trying to call. Great. Here is where I create a new amount object to pass into the constructor. So notice how I'm chaining those things together. I'm calling the constructor. A constructor returns a reference to an object that is constructed, and I'm immediately passing that into the constructor for bank account, which corresponds to this version right here. I then take the reference to the bank account, which contains an amount within it, and I store it in a reference called first. In this second line, I create a reference to a bank account object and store it as the second reference here. So now I have two bank accounts, one that contains 2050 and one that contains nothing. Now I'm going to call the mystery method of the first object, which corresponds to right here. I've got some questions coming. I'll address those in a second. I call the mystery method with the amount that I want to have removed, create a new amount by putting the constructor directly in that. That will add $10 to my first bank account. Sorry, it'll remove $10 from my first bank account and add it to the second account. So that's roughly how we call that one. Let me see what you've got for questions for me. Screen cropped weird for anyone else? Yeah, I'm zoomed in. I'll zoom out for the purposes of not cropping weird, I guess. That's my zoom in so that you can see details, but maybe that's not helpful. All right, so that's our bank account, what we're tackling in our bank account. Let's take a look at the square question. Here, the question was about the square. There's a problem in this class, and the square is an abstract representation of a square. You can see that we have instance variables, side length, and area. Side length is supposed to keep track of the side length of a square, which is going to be two sides, which is the same side length, and the area is the amount of area within it. I edited the question since I gave the exam. In your version of the exam, there was not, in the constructor, there was not a this dot area equals this dot side length times this dot side length. So there were two problems in your version. The area instance variable was not initialized the way it is here. And the second problem was that when you call grow, the area instance variable is not updated. And so there are a couple different ways that you can solve this, and here's an example down here. One way that you could solve it is within the grow method, you could call area equals side length times side length to update the area with the new value of area after you have updated the side length. Now this isn't the only option, and this alone isn't sufficient because in the version that I gave you, you also need to initialize area. But this is the general gist of what's happening. The basic idea is that area is not getting updated when side length gets updated and area is not initialized. Various ways to solve it. Here, that's one of them. Okay, in this question about this block of code, and I asked you to identify 5 compile time errors in this code, you can kind of throw a dart at this code and hit an error. This is just riddled with all kinds of problems. Typically, most people did pretty well on this, meaning they got half or more of the points. I would say the main thing that people got wrong is in a couple cases they made a mistake about what a compile time error versus a logic error was. So the primary one that was the logic error but not a compile error was the declaration of the main method not having the string args. It is true that for this to function as a launching point for your class, main must also have a parameter that takes in string and args. But that's not something that will be detected as an error at compile time. That will be something that goes wrong at runtime. As a main method, as long as you get rid of that semicolon, this is going to compile okay. It's just not going to do what you want it to do. That's the difference between the compile error and the logic error. Otherwise, here's a bunch of examples of things that are wrong. So there's a semicolon after main. That's a problem. There's no quotation marks around please enter these two numbers. That's a problem because it's a string. There's no semicolon at the end of this print statement. These two lines are just a disaster. So X and Y don't have a type declared anywhere. In presumably is a scanner, but the scanner class is not imported, nor is the in variable declared, nor is the in variable initialized. Assuming that in is supposed to be a scanner, read double isn't a method of the scanner class. What we've got is next double. Also, if you're going to call a method, you have to put parentheses at the end of it. So these are just disastrous lines. Down here, system.out.println. Println isn't a method of the system.out class. It's abbreviated ln. And then this sum is, now this is okay. The rest of this line is all right, but there is a logic error here, which is that you're not actually going to have the sum of x and y printed out. what you're going to have is, because the plus is handled from left to right, the first evaluation that's going to happen here is this string, the sum is going to get added to x. And when we add a string to something else, we're going to promote whatever this other thing is to a string, and we're going to concatenate it. So what you'll see first is that this first addition evaluates to a new string, which is the sum is, and then this double will be converted to a string and added to here. So then we have a string, and we're going to add to that string a y. And so this string is then going to have a double converted to a string, and that string is going to be added onto the initial string. So you're never going to do x plus y as doubles. You're just going to concatenate the double representations as strings to the end of the string. So let's say someone types in 5.0 and 6.0 as x and y, assuming the intent of the code gets correctly rendered as compilable code. You're going to see the sum is 5.0, 6.0, not the sum is 11.0. If you wanted to actually show the addition of x and y, the first thing you'd have to do is put parentheses, an extra set of parentheses around x and y, the addition of x and y, so that that x plus y would get accomplished first in this line. A double plus a double stays as a double, and then you have a string plus a double, and the double will get promoted to a string and concatenated to the string. All right, so that's a logic error. That's not a compile error. All right, and I think that's all of them. So let me take a second and see if anyone has any follow-up questions to those particular ones. And while you're thinking about questions, let me go to the last one in Eclipse. I'm not sure I have the solution handy. Shoot. Let's see if the solution is in Canvas. And to go to the solution in Canvas, I'm going to have to go back to where I was. I don't have a solution here. Okay, so let me give you a quick rundown of the issues that we had pretty consistent problems here. Okay, so what our goal here in this question is to create an interaction that looks like this. Please enter an integer, please enter an integer. The sum is, the difference is, the product is. So this was testing a couple different things. One is an understanding of the architecture of the main method. A second one was checking to make sure you understood the scanner class. And the third one was checking your ability to do different math operations, and I guess use the console. So to solve this, the first thing that people tended to get wrong was to use two scanners. So here is an example of one scanner. I think I took off like 0.1 point if you didn't close it, but ideally you would have closed it, and this is a way of automatically closing it for us. Clean this up. All right, so that's one scanner, and so we can get a double here. All right, here is getting two doubles in from the user, and then we need to prompt them as well. So let's see what the prompt was. Prompt was, please enter an integer. All right, it stays on the same line, so ideally we wouldn't enter an integer. All right, and then if we're doing an integer, we better accept an integer. All right, and let's do a second one. All right, so that's two prompts. Please enter an integer. Please enter another integer. Okay, so this is great. This will get our integers input from the user. Some people did something that was more like this. This is okay, and then ideally at the end you would do close, but almost no one remembered to close their scanner. It's okay, that's sort of a professional thing you need to know. It's not functional. Some people did this. They created scanner 1, and then they created scanner 2 to read in the second one. You don't need to do this. You only need one scanner. This is like setting up a checkout at a grocery store. You can read multiple things on a scanner. You only need one scanner. This is equivalent to having two checkout lanes and getting one integer in one checkout lane and another integer in a second checkout lane. That's not really necessary. In fact, it's a waste of resources for scanner. So ideally, you would have done this. Ideally, you would have done this. I don't think anyone did the try, though. The try does the close for you. Okay. Okay. And then the trick was just making sure that you got your output right. And let's take an example of the product is. You have to do all of them, but the product is. And then here's where you run into that error. Or let's do the sum to show it. The sum is 11. All right, so if we run this, and you can see the run. The sum is 12. What? That doesn't make any sense. Why is the sum 12? I entered a 1 and a 2, and I have a plus b here. That should clearly be 3. Let's run it again so you can see what the problem is. Please enter an integer, 123, 1,234, and 99, 3 nines. Boom. The sum is 1, 2, 3, 4, 9, 9, 9, 9, 9. So what you can see here is that it's concatenating them by promoting them to integers. So effectively what we're doing here is we're saying, hey, first take the string and add it to the A, and then after you get the result of that, which is going to be a string, add it to the B. That's equivalent to what we're doing without any parentheses. And what we want to do is we want to force the A and the B to be added before we try and add it to the string. And if we do that, and we do 1, 2, 3, 4, and 9, 9, 9, we'll get the right answer, 2, 2, 3, 3. So that's just a subtle bug. You run into it quite a bit, actually. And that's why I'm sort of liberal with my use of parentheses. The only other thing that you needed here was, or it could have been used, is something like, and we're going to add math.abs, the absolute value of the distance between A and B. Good. That would be how you do distance. And then the rest of them I can go over with you in office hours if you want to talk about what went wrong. All right, so let me stop there with the result of the exam and see if you all have any questions about that. Yes, I was trying to help you see the answers better, but I'm not sure that worked. I'm going to trust YouTube to give you a high quality stream if you ask for it. Okay, I don't see any questions coming in. I'm happy to answer any questions that you've got over office hours, or yeah, that'd be good. Or later if they occur to you, I suppose. All right, so let's connect with Saros and get this up and going, and let's go back to chapter 7. Today should be class 19. I don't have a project set up, so I'm going to go through the process of setting up a project, and you can watch me do that if you want. I'm going to do Eclipse file new Java project. I'm going to give it a name. I'm going to call it class 19 underscore 0224 so that when it sorts correctly over on the side. Everything looks okay here. I want to not create a module info file, and I'm going to finish. I'm going to open that up, and I am going to edit it. For the purposes of sharing with class, I have to do this little bit here where I change how I add my libraries, and I want to add them to my class path, not to my module path. Oops, and I want to add JUnit library just in case we want that. Then I remove the one from the module path. I apply and close to make sure everything's working. I make a new class. I put it in a project in a package I care about, westmont.cs30, and I make a main method so that it's easy to work with, and I give it a name. Oops, I put it in the wrong place. Put package there, put name here. And close one we're working with. And I do a little hello world just to make sure all the system is up and running well. Bash through it, run it. Okay, everything's set up well, and now I can share this with you all. So sharing 19 with those of you that are on Saros, and we'll give it a shot. Here it comes. All right, while that's happening, I am going to get my other bit up here. All right. All right, if it fails for some reason, try restarting Eclipse, then we'll do one more run. For some reason, doesn't always work first time around. I'm gonna let this settle out, and then we'll go through and do a read-only pass, and then we'll try and re-add folks. All right, Ben A, setting you to read-only. Ethan Vaughn, that was fast. Wow, must be a good network. Ethan, that worked well. Nope, Ethan, oh, Ethan Vaughn, yes, Ethan Vaughn worked well. Faith, let's see how that goes. Okay, let's try Luke. No, Luke, wow. Huh, okay, something's not going smoothly. Let's try and send this back down here. My progress bar opened up here. I didn't want it there. Okay. So I just need something just went a little wonky on me. Can either Ben, oh, there we go. People are dropping out. There we go. Okay, maybe we're back. All right, Thomas, you're read only. Monty, you're read only. Got stellar 4 people logged on. All right, let's give it another shot. Addie, there you go. Carson, Josh, sorry people at the end of the alphabet. You must feel abused. Matthew, Landon, Dee Dee, Morgan, oops, Sam, and Trent. All right, shifting Addie to read only. That worked. Shifting Carson to read only. That worked. Josh going to read only. Landon going to read only. Matthew going to read only. Dee Dee read only. This is exactly the thing that I wanted to change in the source code, which is I wanted it to be that when I invited people, I could make it default to read only so that I could cut down on this step. So I tried to edit the software to do that, but was not able to get into the software. I was actually not able to set up the compile environment. So the kind of thing that you all run into all the time when you try and import the zips that I give you, I ran into that problem with the Saros software itself. And of course, it's a little meta because you edit the software in Eclipse. And so you're editing the software perhaps as you're using it at the same time. Let's see, Morgan, you're read-only. Dee Dee trying to shift you to more read-only. All right, Sam shifting to read-only. And let's see. Feel bad, Faith and Trent, you're always dropping out. I'm not sure what it is. It's either a firewall issue or it's a low connection issue, but we'll give you one more shot. Low bandwidth connection issue. All right, while they are trying to wrestle with their network, let's go ahead and move forward. What we've been looking at in Chapter 7 is we've been looking at different ways in which we can use arrays. Arrays are a first data structure. It is a transition from the primitive data types into our object-oriented data types. This transition isn't without a few glitches along the way. And so last class, what we looked at is the way in which when you allocate memory for an array, you have to allocate a specific amount. And once you've allocated it, that's how much memory you've got. And so a common strategy is to over-allocate memory and then to use a separate variable which keeps track of how many things are actually currently in your array. And we use that with a capacity and then a count, a current count, operating separately. We also looked at the way in which you can have two parallel arrays, and two parallel arrays that are keeping track of, for example, an account number and a balance can better be accomplished. We can accomplish that architecture better rather than having two parallel arrays, having one array where each element of the array is an object so that we can keep track of all of the things that are consistent in one, for example, account within as instance variables within that object rather than separate arrays that each have a double and a name and a string or whatever we might be trying to keep track of for a user. So we're still moving towards this idea of getting towards an object-oriented version of the world. And what I want to do is I want to demonstrate how we can create some algorithms around these arrays, because the algorithms and using these arrays are really the power of the computer. And the trick is that when you write these algorithms, you don't know very much about the array. You just know that you have an array and you have to use the length as the array declares the length in order to do your algorithm. So you're working kind of abstractly with this array that you don't know anything about, but you're writing rules for it to try and figure out what the solution is. So let's start here let's make another class so we can have one to work with. So this class is going to be in the same package, and we're going to call it array examples. And we're going to do a bunch of examples of methods that use arrays and do things with arrays. So I'm thinking right now about how I want to architect it. Should we do it as all static methods, or should we do it as an object? Let's see. To understand what's happening best, I think it's going to be best if we do it as static elements. Okay, so we're going to write a bunch of static code, and we'll write some static methods as well. And so by static methods, they're just like methods that exist outside of an object. We just call them without any object-oriented stuff. So I'm going to create an array. Let's work with integers, and let's create an array of integers. So that's my type is integer array. It requires a type and it requires the brackets. And let's call it data, and let's initialize it to an array of some capacity. And that'll help us to sort of get around the idea of not knowing how big something is going to be beforehand. All right, so my capacity isn't defined here. I need to define it. And so I'm going to use Eclipse to help me define it. I'm going to say, hey, please make a new constant. Capacity did it for me. It initialized it to 0. I don't want it to be 0. I'll make it something bigger, like 1,000. All right, so here is a capacity variable we can have access to. We have data, and we don't have anything happening with data. So Eclipse is saying, why are you even making it if you're not using it? So we're going to call a static method, and let's fill it up. So let's call fill an array. So this is our first example of what we can do with an array. What we're going to do is we're going to write fill an array, and what it's going to do is take the reference to our array and put some data in it. There is no method called fill an array, and so Eclipse is complaining, and I'm going to say, go ahead and give me a stub for it. So you can see it says create method fill an array with that int array as a parameter, and it made it for me. Now, as just a point of style, I like to have my main method at the bottom. And so I'm going to move my fill and array up above. Because this is all compiling code, I can come over here to my outline and I can grab that method and drag it up. So I'm going to do that. And then you'll see my source code changes the same way that I just dragged and dropped over on the right. So speed, all about the speed. All right, so to fill an array, we just need to decide how we want to fill it. Let's fill it with a sum of squares of the indexes. So let's create a little for loop. Integer index, we'll have I go up until the length of our array. We don't know how many things are in our array, or we don't want to assume that we know how many elements are in our array. So there are a couple options here. We could fill it all the way and use, well, there are a couple options. We could start with capacity if we assume that the array that we're being given is capacity long. There's no reason to do that because we can actually ask the array how long it is with data.length. We may be working with a variable size, with an array that's over allocated and some kind of capacity that's less than its maximum amount. In order to know that, though, we can't ask the array. If we ask the array how long it is, it's going to tell us its complete size, not how much is being used by the current user. So let's go ahead and add a parameter that says size. We'll call it something slightly different. Not size. We'll call it we'll just say how many. Call it int how many. And so then while I is less than how many, we'll fill it up and we'll put some data in it. Data index I is going to equal I times I. And nothing typed right there. Wow. Wow. Great. I think it's great. Eclipse doesn't think it's great. Why doesn't Eclipse like my eyes? Let's see what it says. Multiple markers. The local variable I might not have been initialized. Oh, that's really helpful. Thanks, Eclipse. What Eclipse is telling me is that when I created I never initialized it. So my loop isn't starting at anything in particular. So let's go ahead and initialize it. So we're intentional about that. Great. All right, so there's a little Java doc about it. And that's an example of using an array. Let's call it correctly down here now. We'll go ahead and fill it all the way up though. We're not using a separate element, so we'll go ahead and fill it to the top. All right, so example 1, filling an array with data. Let's go ahead and, so that we can use this repeatedly, let's go ahead and make another one that says print array to console. So that we can see the results of it. And we'll do the same thing. We'll say, we'll give it the array and then how many things we want to fill it up. Actually, let's to sort of clarify what's happening here. Let's actually make capacity 10. And then we'll only fill up the first 5 elements. But when we print it out, we'll print it out to full capacity. Let's create that method. I'm going to tell Eclipse, make it for me. It put it in the spot I didn't want it. So I'm going to drag it up above main. And so now here in my code, I have my stub. And I'm going to make a new loop here. I'm just going to copy it from here. Change this to how many. Now I have a loop that's the same as when I filled it, but instead of filling it, I want to print it out to the console. And I'm just gonna, what do I want? I want data sub I, and then how am I gonna structure this? Let's put a comma between each element, maybe. Okay, and then I want it all in the same line, so let's do that. Print a line at the end, go to the new line, and do we want to preface it by anything? We'll just go ahead and say, all right, so there's a function, a method, static method that'll print array the console. So now we can run this, we can fill the array, and we can see what we filled it with. Let's go ahead and run that, see how it works. to my console. You can see the console, right? All right, it's a little zoomed out, but you can see it. All right, so what you can see here is we have array data. That's coming from our print and array to console. The data was filled here with fill and array, and we can see we put 5 elements in there. 1, 2, 3, 4, 5. We only put elements in the first 5 positions, and the remaining 5 positions were not filled. That's because we said, how far do we want to fill it? Is 5. So we only went up to 5 in this loop. And then how much do we want to print? Well, we're going to print all of it. And so in this case, how many is now 10? And we went all the way to the end of our array and printed all that data out. Had some nice formatting with our array data and a new line, so it all ends up on the same line. The only thing not good about this formatting is that we put a comma there at the end, and we could put a special, should we do that? Okay, let's do that. If I is less than how many minus 1, then we'll print a comma. We'll get rid of the comma here. All right, so what we're doing here is we're making it so that we only print a comma if we're not at the end. And then if we rerun it, we'll fix that output. There we go. So we don't have a comma at the end. Nice. Okay. If we decide to fill it to, notice that we end at 16. If we take it up to 7 and we rerun it, the data in our array goes up here to 36, but we're still printing it at full capacity. If we decided instead we were only going to print it out to like 3 elements here, although the underlying data structure has 10 slots in it, we're filling it up to 7 and we're only going to print out the first 3. So you can see that we've decomposed the idea of filling. We've actually decomposed three ideas here. One idea is how big is our array at max capacity? That's the static constant capacity. We've said how much data are we going to put in it? That's dictated by the fill and array method. And then we've printed out how much we're going to print out and print an array to console. First 2 methods. Any questions about these guys? Any questions about that first example? All right, nothing yet. All right, let's take a look at another one. Let's calculate the sum of the elements in our array, and we will do a similar thing here. We will say sum an array, and we will pass the array that we care about, and we'll say how many elements do we want to calculate the sum of, and let's do our full capacity. And what do we want to do with the result? Let's capture the result. Great. Now you can see how I stubbed it out without having written it. And by using this, this is a little bit like test-driven development because I've passed it some parameters, I've received a result, I've assigned that result to sum. So this is enough information that if I now go and say, hey, Eclipse, write my array, careful that I select the right thing because the first selection it's offering me is to change my method that I'm calling to a different one that's already written. That's not what I want. What I want it to do is I want to stub out an array, a new method for me. So boom, it made it for me down here. I'm going to lift it up, put it above print an array. Come up here, we're now in sum an array, and again, I want to change the automatic variable name to something that makes sense to me, so how many? And I want to take my for loop here, and I'm going to drop it here. To calculate a sum, we're going to need an integer, we're going to need an aggregate variable. So call it my sum. Start it with 0. Our integer is going to go to 0 up to how many, and each time we go through the loop, we're going to want to say my sum plus equals 0. Or plus equals not 0. Data sub I. And we're going to return my sum as a result. So that'll calculate the sum. Now remember, we have the ability to do a fast enumeration. So we could say something like that. And that's a fast enumeration. That's great, but the only thing that we don't like about that is that it's going to go through every element of our array, and we don't want to go through every element of our array. We only want to go up till the amount that our user told us to. So we can't use fast enumeration if we don't want to traverse the entire array. So we're going to leave it like this. And we're going to return the right variable name. We're going to go down to main, and then let's print out the sum. All right, so let's do something that we can keep track of. Let's fill the first 3 elements, and we will print everything to the console. And we're going to sum everything in it, so that the things that we don't fill are going to be 0. So we should see system.println. It's not a parameter. We want to concatenate it to the string. Great. We run that out. We can see 0, 1, 5, and a bunch of zeros. The sum is 5. Great. Let's take another one. Let's calculate an average. All right, so the average is going to be, could potentially be a floating point. So we'll call it, let's call it the mean. And we'll say average an array, same thing. And we'll say, hey, Eclipse, please make that for me. Again, create a method. Boom. It stubbed it out down here. I want to drag that up above print. Great. And I'll go up here and take a look at the average. And I'm going to start with my sum because it's very similar. And we're going to change it so the second element is how many. All right, this is going to calculate the sum. That's not what we want. What we actually want is we want to calculate the average. And so after we calculate the sum, we have to divide by the number of things that we summed over. So there are a couple different options here. One, we could introduce a count variable. So we could say int count equals 0, and each time through the loop we could say count plus plus. We could say if count is greater than 0, then we return my sum divided by count. That would work. We have to be careful about integer division here because we don't want an integer divided by an integer. We want to actually get the correct value. And so if we do this, we better change. We need one of those. We need one of these to be a double. So we could do a typecast. We could say, hey, make the bottom one a double before you divide it. That's an example of typecasting. Typecastings are a little bit sketch. So rather than doing typecasting, I'm going to go ahead and just keep track of it, the count as a double. And I'll say count plus equals 1.0. And the last thing we have to do is if count is 0, we have to say, what do we do if we didn't actually do anything? What's the mean? And we'll just go ahead and say the mean by default is 0. We want to make sure we don't divide by 0 because that would be a mess here. All right. Questions or comments while we run this and see if we get the right answer? Go down to main. All right, run that out. So the average of our 10 elements is 0.5. So this is a little tricky because you have to be careful about what you're averaging over. We're averaging over our full array length. So what we're calculating is 0 plus 1 plus 4 plus 0, 0, 0, 0, 0, and then we're going to divide all by 10. And so 5 divided by 10 is 0.5, and everything looks pretty good there. Let's do one more, and then we'll look at something else. Let's see. Let's do. How about we remove an element maybe? Let's remove an element. Okay. So what we're going to do here is we are going to, do I want to remove an element right now? Actually, I don't think I do want to remove an element. I think what I want to do is I want to introduce the idea of an array list now. Because in order, we'll look at the remove and insert at in another point. Okay, so now here's our big switch. This is our big move. We're now going to move from doing primitive arrays to working with array lists, which are the Java version of, or the object-oriented version of this primitive type. So I'm going to now make a new class. I'm going to call it array list examples, put a main method in there. And now I'm going to put these side by side, or I'll put them on top of each other so that we can see what we're doing here. So you can see that on top, what I'm working with is I'm working with arrays. And now down below here, I'm going to work with array lists. So what's the equivalent of making an integer array using array lists? Well, the syntax is a little different. First of all, our type is array list rather than an int and the brackets. So it's kind of like we're explicitly saying that we've got an array list. That's just what it is. Then we have to say, what is it we're going to store in our array list? And we use a special kind of notation called diamond notation, or it's called a generic. And so that is a less than or a greater than symbol together. And then into that, we put what it is we're going to store in our array list. So in this example, what we're doing is we're making an array list that is going to contain integers. This whole thing is the type. We're composing it by typing things together, but this is the type in the same way that this is the type here. Same thing. Let's give it a name. We'll say data. That's now the variable name. And now we want to initialize it with an array list of the appropriate size. So like above, we're going to say new. We're going to call a constructor. We're going to call the class array list integer. That's the type, right? And now we're going to call the constructor for it. And the constructor doesn't take any variables. An array list has to be imported, so I'm going to ask Eclipse to import that for me. Thanks. You can see line 3 added the array list. And now I have this great new array list present. I can now work with it, and the way that I work with it is slightly different. Whereas before, I would use the square brackets, I'm now going to use methods to do everything. So for example, if I want to, let's do it with, let's make fill an array. All right, so we're going to call fill an array list. And we're going to pass in data, and we're going to say how many elements do we want to put in it. Now, one thing to notice here that's different about my array list when I constructed it is I didn't give it a maximum capacity. One of the ways in which array lists are stronger than, or a little bit more flexible maybe, than a primitive array is that it grows based on what we need at any given time. So we don't have to set a maximum amount in advance. We can just use it as we need it, and then it'll grow as we need it, grow on demand. The second thing to note is that what I put in the angle brackets was not a primitive type. It was the object-oriented version of the primitive type. So I can't do this. You're not allowed to use what's called the Java Collections Framework. ArrayList is one of the Java collections. You can't use primitive types here. Everything has got to be object-oriented because we're moving into an object-first, primary object-oriented world now. Integer is almost the same as a primitive int. It's just an object-oriented version of it instead. When we fill our array list, we're going to have to edit this a little bit. Let me get a little bit more screen space since you can see it all now. Java will also offer to write it for me, so go ahead and create that. Put it in the wrong place, so I want to move it up above. Oops. All right. And I'm now going to create a for loop. Looks a lot like before. You can see that my incoming parameter is reflecting the fact that data is an array list integer. And now if I want to put something in it, what I'm going to do instead is I'm going to say data. Now before we would have done this, right? So instead of doing that, we're going to say add. And we're going to add something to the end of our list. So we don't necessarily know how much is in there, but we're going to add something to the end of it. So this will fill up our array as necessary with however many elements we wanted. And then we don't need to return anything, so we'll just get the result. Let's also now print array list to console data. And we're not going to say capacity because we're going to assume that because the array list grows as we need it, it's never going to appear to have more capacity than what's actually being used. So it's just going to have the elements that we need, and it will grow as necessary. So when we print our array list to console, have Eclipse make that for me. Thank you. And then move it where I care about it, above main. Now I'm going to print an array list to console. We don't have the capacity issue, so we do have the ability to use fast enumeration now. Little prompt to set us up. All right, and then we'll do our fast enumeration. What is in our array list are integers, so we have to say I, and then it'll go through data. This is a real win right here, what's happening right here. And we're going to print out data. Okay, so now normally in an array, we would have done that. Print out data sub I. This isn't an array, it is an object-oriented approach to doing an array, so we're going to do get. And get will give us element I out of our array. We'll print element I out of our array, and let's see. All right, the logic for not putting a comma at the end is a little bit complicated, so I'm going to skip that for the time being and just have an extra one at the end. All right. We'll run that as a Java application and see what we get at the bottom. We got an error. That's my error. Array list data. Okay, something when I printed it out. Oh, I didn't have to, sorry. I got so interested in showing you how to do it that we don't actually need to get it because my fast enumeration pulls it out for me. I'm gonna have to go back and explain what just happened. There we go. There's our array list data. Try that again. All right, array list data 0, 1, and 4. Okay, let's look at. Okay, we're sort of at the end of our time here, so that's a good foray into our array list for starters. We're going to need to go through and look a little bit more carefully at array list. Let's just in this on Eclipse real quick. Let me just show you some of the different methods that we've got. We can get element I. We can set element I. We can do a bunch of different things to it. If you do data dot, you can see all the different things that you can do. You can clear your array, you can clone it, you can check if it's empty, you can do a bunch of stuff that we haven't discussed yet. You can remove elements from it. You can ask how big it is with set.size. Probably should have done that rather than fast enumeration. Oh well, we'll work through it. All right, let me stop there and address any questions that you've got. Let's see, I'm going to go back in game. So shifting in game, double broadcasting and shifting. Okay, double broadcasting, single broadcasting in YouTube. We are saying goodbye. This is the end of February 24th, Wednesday, and we are wrapping up class. We'll see you tomorrow. All right, see you later.